Okay, hello, 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 hello in the dark. Hello in the dark, hello in the dark, hello in the dark. Yeah, I hope all of us are well. Hope all of us we are good. Long time, long time, long time indeed. Hey Bopel, what meanings? What is the meaning? The 100 Rand classes are still available. From where? How? Where did you hear that? Pearl must share where she's getting this information. Yes. Oh, 100 Rand classes. My goodness, my goodness, my goodness. Yo. Yeah, hopefully there's no people scamming other people on my behalf. I would hate that be the case because my goodness, 100 Rand classes. Yeah, that's hectic. That's hectic. All right, so I'm hoping that we have is it the grade 11s? Grade 11 supposed to be here. I think yeah. So today I just it's like what you call emergency, one of those situations of like grade 11s, yeah. So I will be sort of like giving messages every once in a while about sessions that will be happening for respective grades. So today I specifically sent a message to the grade 11 group and alerted them that there would be a session that would be happening, and the session would be one where we are continuing where we left off. Please, good people, I understand that, and let me just get an indication in the comment section. Where are we in our respective schools? Like, what is happening? If I was to step into your maths class, possibly, let's say today or tomorrow, what is happening in your classes? Okay, that's what I need to understand. Ngwango, the grade 12 classes, like I said, I will be announcing to the respective grades as time goes by as to sessions that I'll be holding. I did explain to those who are probably joining for the first time that my time for having daily sessions pretty much ended the minute schools restarted, because I do not have the flexibility of time as I used to when it was holiday. And so I have to then obviously now check when I have open gaps, and then when I have open gaps I can then have a session with learners, with regards to a particular topic for a particular grade. Ukamoji is asking, is it possible if you create a group so that we can gather and learn online? So the group, there are various groups that have been created already since, I guess you could say, the beginning of whenever we started. And so, yeah, I do not intend to extend or to have more groups or to have other groups. There are those groups. But I will say, guys, that I'm intending to, I'm hoping at a specific time I'll be able to host a particular individual. I want to host a particular individual that is a math teacher from one of the areas that I'm privileged to work in. All right, so there is a specific special someone that I will be having at some point so that he can come here and maybe even share those things. Hi, Bo Presh. We don't even have a maths teacher. What are you talking about? You don't have a maths teacher at your school at the moment? That is really sad if that is really true. Okay, so I just asked, guys, just for the beginning, for the grade 11 session, if you guys can just let me know what's happening at your respective schools. Have we started? I saw someone say, Comfort Kambani said we'll be writing the baseline test tomorrow and the test on Monday. baseline test tomorrow. All right. So the test that is supposed to sort of like check if you still have the knowledge that you gathered from last year. That's a baseline, most, ne? Baseline. Presh, that is very sad. If you don't have a teacher yet, that is very sad. Kios says we wrote a baseline test today. So how was it, Kios? How was the baseline test? Did it take care of you, or did you take care of it? Pressure, as your now maths teacher is abusing the free periods. Meaning does that mean that your teacher is actually coming in and just utilizing the free periods to teach maths? I love it. I love it. Now that's a committed maths teacher, and who is this? Precious, you should be like excited and gung-ho about that. Yeah, you should be so gung-ho, it's not even funny. Uhle, how can I join the maths group? Get in touch with someone who is in the live session at the moment, who is actually in the group, and they will kindly add you there. Get someone's contact details. Hopefully those people who are on the group will actually like avail themselves in the comment section so that they can do such. Boitumelo is saying, sir, please do solve for x. Which solve for x? What solve for x are you talking about? Are you talking about exponential equation type solve for x, or are you talking about solve for x as in like quadratic equation solve for x? Which one? What are you talking about? Smonga Konge says, can I be added to? Hopefully I have grade 11s in the house. Ne? I don't want any other grade. A grade 12 though, that is here, will benefit from attending this session, because one thing is for sure, a grade 12 learner should be in the position of being able to do grade 11 work without even thinking. Okay? Yeah. Boitumelo says, sir, please do identities. Boitumelo, are you... Boitumelo, do identities. Are you intrigued already, Boitume? Is that what you are telling me? Okay, I'm not here to do trig, by the way, so definitely not prepared for trig. Okay, remember I did say that I am continuing from where I left off, and where I last left you guys was I left you hanging with the quadratic inequalities. Okay, so identities not yet, my dear. But as we progress along, obviously, as we progress along the progressive path of the syllabus for the grade 11s, we'll eventually get there. Unfortunately, we're not there yet. Okay. Yes, Kamoji is saying if there's a person on this live who is knowing about the group and who is in the group, please do comment so that Diegamo can be able to have access to the group and be able to join it on WhatsApp. Yes, ASAP. Okay. And yes, people, I don't know where the 100 Rand amount came from. I have not, as of yet, extended charging of people for being members of the WhatsApp group. So if someone is doing that on my behalf, please kindly return my money, because it is money that you are collecting that I did not ask for. Do not be scammed by anyone to collect money on my behalf. I do not and have not extended my services of doing what I'm doing here on this platform for money at all. So please, can I ask that if there's someone who's doing that but is doing it under my name, that person must not be entertained. Do not give him the time of day or give her the time of day. All right, but guys, as I said, I'll be picking it up from quadratic inequalities. That's where I'm actually at, because that is as far as we prodded along in our progression path of the maths journey that we were on. So that's where we at. We are in quadratic inequalities. If you are someone who's here and you're like, man, I want something that you have done earlier on to be done. Like for instance, you want me to do exponents. You want me to do exponential equations. You want me to do simplification of exponents. Then one thing I can tell you is that that's already done and dusted. You can go to my YouTube channel and watch the grade 11 exponent sessions that I held with this group earlier on, like literally in December. I have uploaded the 4 sessions that I did with the grade 11s. It's just that at the beginning, you're just going to have to deal with a black dark screen because I do not start usually immediately. As you can see, I'm rambling at the moment, still trying to buy time so that people can join in. So usually it's a dark few minutes, and then after that you'll see my hand move and me starting to write things on the white paper that is in front of me. So please make sure that when you do watch the live session or the recorded live session that's there, you please go ahead and do what? Fast forward a little bit so that you can actually get to the part where I start teaching. And that is for all the raw, live, recorded sessions that I've uploaded on my YouTube channel. They are there, guys. You can watch exponents at your own pace. If you have questions for me, what's beautiful is that if you are in the group, then you can ask me directly those questions with regards to what you have watched in the video. All right, and then I can explain that to you one-on-one type deal, you know. And like I said, I have not as of yet started asking people to give me money for what I'm doing. So for now, you can enjoy the freebiness of the things that I'm doing until further notice, right? until good further notice. But for now, I just want you to dive in the maths, enjoy the maths, well up in the maths, marinate yourself with the maths, be one with the maths, love the maths, fall in love with the maths. Don't fall out of love, fall in love, fall madly and deeply in love with the maths. And then one step at a time, we will get to a place where when maths becomes a joy, then you can do it without really putting that much time or effort. The name of the YouTube channel, Hlehle, you can go to my bio. Be my bio. On my bio, there are 2 links. One of the links is to the WhatsApp channel. You can just ignore that one. Go to my YouTube link. Okay, it's called Maths is a Game as well. Everything that's sort of like branded with me, you know, in it is called Maths is a Game. You can just go to the YouTube channel, Maths is a Game. You click on the link, it will send you directly to the link. To the channel itself. Then you go to the grade 11 playlist. There's a playlist for the grade 11 sessions that I've done ever since I started teaching term 1 work for grade 11. Then you can watch those sessions in succession, like one after the other if you want. They are very long, okay? You know what I mean? Very long, but very rich, you know. And like I said, they are raw sessions. No editing, no nothing. It's just the pen and the paper and the maths. So you can watch those at your own time, your own pace, and then hopefully as you progress along, you can actually learn something from those. So I did exponents, I did simplification of exponents with multiplication and division, did addition, you know, and subtraction, where there's exponents with addition and subtraction, where you have to take out the highest common factor or where there's factorization involved. Then I did equations, okay. Then I did exponential equations. Like I said, I did different types of exponential equations because exponential equations are not the same. There's exponential equations where you take out the highest common factor. There's exponential equations where you have to actually apply a K method and trinomial factorization. You know, there's exponential equations that have like difference of 2 squares in the mix. So please do those. Check those out. You know, and it's so logical, and there's a development of one concept to the other. You can check those out. You can check how I do the examples and so forth. All right, and then from there, there's exponential equations that have to do with variable bases, where the base is a variable. You have rational exponents. All right, where the rational exponent itself has different components to it. You know, when there's an even number in the numerator and an odd number in the denominator, what happens? If there's an even number and on the other side of the equal sign, there's a negative sign, what happens? There's different things that are there. Okay, so if you watch those YouTube channels developmentally, even if you don't have a teacher at school, those sessions should be of great help and benefit to you. Then if you have any other specific questions related to exponents, you are more than welcome to freely shoot those questions at me, and I can address them as is fitting to you. All right. Then from there, we started with quadratic equations. Okay, we started with quadratic expressions, completing the square of a quadratic expression. We did solving for x, 3 different types of solve for x, different methods, and when they are used. We then also did equations, solving those equations using those different methods. And then we looked at quadratic inequalities. We also looked at equations that have to do with fractions, where in some cases you have to use this method of the K method, depending on a repetition of an expression, and all sorts of different types. So it's your onus to actually check those out. Okay, so someone like Presh, for instance, was saying we do not have a maths teacher as of yet. I don't want someone like Presh losing losing her mojo, or losing her flow and continuity in maths simply because there's no teacher present. That cannot be the case. So that's why those videos are there. They are supposed to supplement any sort of like shortfall that is there. So that at the end of the day, you do not lose out, you do not miss out, you do not find yourself on very shaky ground. And then when the time is fit, all right, and I had done this already for the maths group that was actually with me from the beginning. Those who were there at the beginning will know that after we did exponents, there was a test that I said people can write. Those who wrote the test, they approached me, they let me know that they are ready to write the test, they wrote the test, okay? And let me just report and say that there was one learner in that particular group of ours that actually scored 100% for the test that I had actually set, and I was quite proud of that particular learner. So if you ever are able to converse and communicate in the group with him, this particular learner, his name is Gift. Gift actually got 100% for that test that we wrote on exponents. And it was quite phenomenal. Then, like I said, as we continue with these topics that we are doing, we are going to get to a place where I'm going to say, all right, there's a day when I'm actually going to send a test in the group, or at least I'm going to ask you to request the test from me that you will be writing, which will be on the topics that we have covered from when we started quadratic expressions up until where we are going to end, where I see fit we are going to end. So all of those things, guys, they will happen with time as we get to cover certain aspects. I hope that is clear. I hope the network is networking. If there's any glitches, any laggings, I hope you'll let me know in the comment section. Are we good so far? Is the network okay? I'm going to actually now start, guys. I'm going to start. I am going to now start. Lagging fine, network okay. Things seem to be spot on. So like I said, we ended with quadratic inequalities last time. That's where we ended. So I'm actually going to pick up from there. Okay, I'm going to pick up from there. And the Presh is now telling me that we are waiting for those corrections, meaning you guys are still awaiting the corrections. Funny thing is, I think I actually did not. Okay, let me just see if I can't locate those corrections. I'll return very soon. I just want to locate the corrections. So just hang tight there. All right. Yes. All right, we back here. We are back here. Okay, network okay. My grade 11's network is okay. Are we fine with the network? I just want to confirm that before I actually really swing in with a, with like one of those heavy laden fists Off note, I just want to check and verify network connection wise we are good. Can you guys see this? Is this visible? Are we good? Can we go? Can we snap? Can we good? Are we good to, are we ready to rumble? Network okay? Network okay? Confirm, confirm. Comfort is saying yes. Right? Network is fine, network is fine, network is flowing, network is sweet, network is good. Network is networking. All right, so here we go, guys. Just a quick recap, ne? We'll remember that there was a method that we would use when we are solving inequalities. A beautiful, sweet method, might I add. A very beautiful one. Remember, the method was, step number 1, we need to write the equation in standard form. Step number 2, let me just, sorry guys, let me just do this. Okay, I hope Gift you were here when we celebrate. You were the one that got the 100% for that exponential test, whose corrections I'm still yet to do. But seeing as though you totaled that test, it seems like the corrections basically you had them even before the test was written. It was a matter of you writing the test and just confirming that you had mastered the exponents, which is good, right? So I'll be waiting to hear when finally you guys are a bit ahead in the syllabus and you have advanced, and then when you start writing those class tests at school, then I'll hear from you how you did in those exponents, because hopefully that test kind of gave you an idea about, okay, yeah, and most of you it did as well. So yeah, the tests are there to learn. So if we look at the method, guys, just very quickly here for quadratic inequalities, all right? So yes, people, like I said, if you want to catch up on what has been done so far, please by all means do go to the sweet, amazing YouTube channel. You can check out everything else that you may have missed and that you feel like you still need to catch up on. But Tina, we are here at this stage because we've been at this like for so long. This is grade 11, all right? And here we go. So step number 1, whenever we are solving a quadratic inequality in grade 11, also grade 12 knows that they should be able to know this. You need to write the equation in standard form. That's the first step. Secondly, you need to factorize. You factorize the what? The quadratic equation that is in standard form. Failing which, if factorization is not possible, we know that we can utilize the beautiful what? Quadratic formula. You will know if you are in the group when the time comes, dear grade 9 student. Okay, that goes for all students. Grade 9, grade 10, grade 12, grade 9, grade 8 for now. Okay, you need to hang on because I have not as of yet launched my start with you guys as of yet. So unfortunately, you guys, I think you just need to stick with your teachers, stick with what the teachers are teaching. We will see each other, we'll find each other midway somewhere. Okay, but I need you guys to go and actually allow your teachers in that new school of yours. You need to acclimatize to that new style of learning and allow yourself to be there. I will catch you, as the time progresses, grade 8. So grade 8 for now, hang on and hang on dearly to the teachers that are new in your lives in the high school that you are in. But for other groups, that will be announced as time goes by. Today is grade 11, and I will not be doing any other grade today. Thank you so much. So we write the equation in standard form, we factorize, okay? Or if we can't factorize, in order to get those roots, we will use the quadratic formula. Then the roots, we need to ensure that we write that amazing, sweet word, we need to write these two letters, CV, that stand for what? Critical values, okay? The roots of the equation, okay, we usually get the roots of the equation, but those roots now, in quadratic inequalities, we actually refer to them as the critical values of the quadratic inequality. So we write CV to indicate that these are critical values, and then we write them next to that CV. Then step number 4, important to represent your information that is basically related to that quadratic inequality. You represent that information in a number line, or in that number line, you can actually represent it with that parabola. Very important, okay? Smiley face all the way. Concave up parabola. Step number 5, you write your solution as an inequality, or something else I didn't mention last time, you can use interval notation to then write your what? Your solution. Interval notation is just another way of expressing an answer whereby there's a range of values that are basically representing the answer that will satisfy the inequality. So these steps, they are very important. Writing the equation in standard form, factorizing, finding the critical values, representing your info in a number line. You can represent it in two ways, either with the number line, or the parabola on the number line. And then last but not least, writing your solution as an inequality, or you can basically use interval notation to represent your solution. Okay, so before I jump into let's just jump into the corrections, because I know people are burning and they're dying. It's like there's a burning in their hearts to basically have the corrections of the game challenge sorted. So in our previous game challenge, we had the following questions to basically answer, and some of you were kind enough to send me your responses and how you did your questions. All right, people, please take note. So first step, you remember, what did we say in the method? We need to write the equation in what? In standard form. And I think I had added that let's ensure that our standard form is represented with the coefficient of the first term, the x squared term, where a is positive. Right? Where a is what? Is positive. Right? Please ensure that your a is what? Is positive. So look at this equation. We can see it's negative x squared plus 5x plus 6 less than 0. Our a, the coefficient of x squared, is negative. So step number 1, what do we do? Because our coefficient of x squared is negative. So what do we do? Anyone in the comment section can please comment and then state what will what I have done do to the inequality? Divide by -1, Presh. So much for not having a teacher, at school. Yeah. Presh, by the way, let me tell you something. I actually didn't have a teacher in my grade 12 year. But you know what? End of that year, I got a distinction. Why? Because sometimes having a teacher is the best thing that can ever happen to you at a school. Why? Because it forces you to do things that you would never do if the teacher was there. And that is what? Become independent as a learner. So, good luck to you. Divide by -1, precious. Amen. And as Gift says, divide every term by -1. Not just divide by -1 that term, but divide every term. So practically speaking, this is what we would be doing. And I love what Gift is saying. Every term in the equation, we divide it by -1. What happens as that happens? It's like this inequality sign changes direction. All right? Yeah. So obviously that would have been, so this would have been the question, right? This would have been the question. Okay, let me rewrite it. Oh man, this is funny. Okay, let me rewrite it. There it is, ne? That is the question. Next step, like you said, divide by -1 every term. And what happens? This inequality sign changes direction the minute you divide by -1. It changes direction in that moment. So that's why people sometimes just go ahead and they don't even show this particular step, but all of a sudden you see this standard form, x squared minus 5x minus 6, and already the inequality sign as expressed in the original equation has changed direction because we divided by a negative. All right, so this is basically step number 1 where marks are awarded. Marks are awarded. Are we together? Write the equation in standard form where a is positive. Check. Step number 2, factorize. So yes, we can see that in that expression, x and x give us x squared. Negative sign for a constant means the signs in the brackets are different. The sign of the biggest factor will be negative. The factors of 6 that qualify to make negative 5 are, and in the comment section, the responses, they flow one by one, and the Mampana says negative 6 and 1, right? Yes, we are definitely factorizing Presh at the moment, on the go. Junior LM says 3 and 2. Okay, if we look at Junior and the response that he gave, 3 and 2, would 3 and 2 help us get negative 5 if the signs are different? Remember, negative 6 suggests that the signs inside our bracket should be different, right? Meaning there will be a negative and a positive sign. Take note of this thing, guys. The negative sign suggests that the signs inside the bracket will be different. That's what you guys learned in grade 9 and grade 10. The signs inside the bracket will be different. And because the negative sign in the middle term is there, we then also note that the factors of 6, okay, the highest factor for those factors of 6 will have a negative sign. So now we need to consider two numbers that if we add together give us negative 5. So that's why 3 and 2 don't qualify. But 6 and what? And 1. So 6 and 1, where 6 is negative and 1 is positive. And you can verify. What's negative 6 plus 1? Do we get this middle term if we add these two? Because when we add the numbers, they need to give us the middle term. When we multiply the numbers, they need to give us the constant term. Junior LM, I'm glad you understand. And I'm glad you now have what? An angel, sort of like what you might call an angel halo above your head. Amen. Hallelujah. So x minus 6 into x plus 1 is greater than what? Than 0. Second mark, getting my factors. 100% correct. Okay, where I can factorize, you must definitely factorize. Next one, CV. Please, people, you are not writing the solutions of x as your actual solution. You are identifying or finding your what? Your critical values, which are the roots of the, if this was an equation, not an inequality, then the roots are what represent our critical value. So what are the roots of these factors? The roots are, what would make this bracket 0 if x is equal to 6? And the second root is when x is equal to negative 1. Be very careful, my boy to melon. Must be very careful, my boy to melon. Plus 1 minus 1 plus 1 will give me 0. So x is equal to negative 1. It's like we are transposing the 1, or it's the additive inverse of positive 1, which is negative 1. The additive inverse of negative 6 is what? Is 6. Okay, are we together? Critical values. Next step, number line. Now you'll remember that when I had my actual standard form where a is positive, that means parabola, smiley face. The roots of the equation, if it was an equation, the critical values, the smallest critical value is negative 1. The biggest critical value is positive 6. These represent in a function the x-intercepts. So the roots, x-intercepts, roots, x-intercepts, critical values, negative 1 and 6. In a number line, negative 1 first, 6 follows, right? Then, remember what we had interpreted from this. What does this mean? greater than 0, it means above x-axis. It means what? This means above the x-axis. Remember, this is the output. The output means for y, this is where y is positive. Greater than 0, this is for y, where y is positive. Where is y positive? Above the x-axis. Does that make sense? Cartesian plane, remember Cartesian plane? Cartesian, y-axis, x-axis. This is the x-axis. All the values here above are what? 1, 2, 3 positive numbers. Underneath the x-axis, -1, -2, -3. So these are values of y that are negative. So below the x-axis, we are negative. Above the x-axis, these are positive y values. Okay, so that's why I'm saying output. Output means for y, where y is positive. Where is y positive? Above the x-axis. Yeah? I hope this is clear. Greater than 0 means for y, where y is positive. Where is y positive? Above the x-axis. Where do we have above the x-axis? If we actually move from negative infinity, we go, and we get to this critical value, -1. From negative infinity, we get to this critical value, that's -1. What do you observe about the function? Okay, it's like in this region, which is like from negative infinity to -1, the function is above the what? The x-axis. This is where the function is what? Positive. For y, it's positive, the function. Let's continue. From -1 to 6, what's happening? The function is now below the x-axis. We are not looking for below the x-axis because it says greater than 0 for y. That's where y is positive. That's above the x-axis. So we are looking for above the x-axis. So our first answer that we can see is that when x is less than -1, when x is less than -1, oh Shem Karabo, you are angry. Oh, be okay, okay? Karabo, be okay. Where x is less than -1, guys, the function is above the x-axis. That's where we have our answer, above the x-axis. When x is smaller, yes, very good. I love it, Junior. Where x is smaller than -1, when x is less than -1. Guys, please put Karapo in your prayers. You know, anger, guys. Anger is such a deceiver. Such a deceiver. The spirit of contention is of something else. Anger. Just anger. Be slow to anger, guys. That's why the Bible says that. I think there's a reason. You know, they know that there's disaster where there's anger. Okay, you see now, Karapo just wants to live because of anger. You can see that. Hi, guys. Then from -1 to 6, the function is below the x-axis. That means our answer is not here. We have no answer from -1 to 6. What about from 6 all the way to infinity? Chenny. We have a answer because the function is above the x-axis. So when x is greater than 6, in other words, I'm looking for my good friend to say the nice things. Junior LM, please give me the sort, because here you said when x is smaller than -1. Me, I'm saying here now where x is greater than 6. But give me the more sort of like layman's terms of saying it. Where x is, I'm waiting for my friend, the Junior LM, to tell me, to give me that sweet working way of just saying it. Where x is greater than 6, or we can say where x is, okay, all right, okay, I think Junior must have been lost in translation there. Where x is bigger, okay, than 6, the function is above the x-axis. So that's why we say the answers lie in those intervals. It simply means that substitute any value less than -1, substitute it into this function. I mean, in this inequality, the inequality will be satisfied. If you take any value, let's take -2. -2 lies in this region. Take -2 and put it here. You get -2. So -2 minus 6 gives you -8. Here -2 plus 1 gives you -1. And negative times a negative gives you something that is greater than 0, meaning it's positive. So yes, really and truly, all values, any value from this region will basically do what? Will give you the answer that satisfies. It's fine. If you use the line graph, that's fine. That's no problem. You know, -1 and 6. Yeah, then you have this guy this side, and you have this guy this side. That's also fine. All right? Boitumelo, it's fine. Whatever floats your boat. Take your thing. What do you want to take? Oh, you have to take the time. Oh. Good job. Okay, let's move on to the next one. 3x squared minus 2x less than equal to 1. So this one, step number 1, standard form. Standard form means the following: 3x squared minus 2x minus 1 less than equal to 0. That's our standard form. Okay, then step number 2, we need to be able to factorize this, right? Is it factorizable? Definitely it is. Okay, definitely it is. Okay. Yeah, definitely it is. Okay, this is utilizing my method, all right, where I just simply factorize and choose the appropriate factors. So we have 3x plus 1 and then x minus 1, okay, which are factors. Really, if you multiply it out, you say 1 times x, you get x, and then 3x minus 1, you get -2x. You add those two together, -3x plus x gives you that -2x. And then 1 times -1 does give you this -1. So it's sort of like that trial and error method. Some people will use the AC method, or some people will use alternative methods, as long as we are able to get to the what? To the factors, and then be able to get the what? The critical values. Maybe someone else, because they felt like, hey, I cannot find the factors at all. You know, they will use maybe the quadratic formula and get the critical values. Okay, we definitely would not penalize someone who does that, because that was the method that came at a time when they basically did not really know what it is they ought to do. You know, but remember that we ideally want to use the factorization method whenever factorization is feasible. Okay, and then to utilize quadratic formula only when factorization is not feasible at all. What are our critical values here? X is equal to -1/3 or x is equal to 1. There they are, two critical values. Then, of course, simply put, we do the same thing there. Smallest critical value, our first critical value, biggest critical value, our second critical value, and really and truly that's how they are. We interpret this. What does this mean? This means for y, what do we know for y? This is where, what does less than mean? This is where y is not positive but is negative. And equal to 0. So it's negative or equal to 0, because less than or equal, it means negative or equal to 0. This is very important. Negative. Where are things negative? They are negative below the x-axis. All right, very important, below the x-axis. So where is it below the x-axis? This is the situation, guys, where your solution becomes a compound inequality. It will not be separate like this. When the answer is above the x-axis, for a concave function, the answers will lie away from the critical values. X less than -1 away on this side, x greater than 6 away from this side. That's why I usually add this for my learner, and I say above the x-axis, away from the what? The critical values. Above the x-axis, away from the critical values. Hence, I call this AAY, above, away, AA. So I know above the x-axis, the answer lies away from the critical values. Away, x is less than -1, away from this on this side, x is greater than 6, away on that side. Separate, away, separate, you know. Then this one, below the x-axis. Okay, check this out. Let's check where is this below the x-axis. Is it below the x-axis on this side? No, you can see most here. Where x is less than -1/3, the function is above. So the answer is not there. What about from -1/3 to 1? What's happening? The function is below the x-axis. Here it is equal to 0, which is very important. Equal means on the x-axis. On the x-axis. So this needs to be negative, meaning below the x-axis, and it needs to be equal to 0, which means on the x-axis. So where is it? Where's the answer? Where does the answer lie? It lies between -1/3 to 1. Are we together? Because the answer lies below the x-axis, between the critical values. Below the x-axis, between the critical values. So your answer is joined. It is 1, like this. It's a compound. We call this a compound inequality. You see the inequality signs? They open their mouths to the right, to the right, to the right. Yeah, to the right, to the right, to the right. Yeah. They open their mouths to the right. Nothing about one opening to the left. No, guys. One way only. One way to the right, where the sheep are. One way to the right where the sheep are. Very important. One way to the right where the sheep are. They are on the right, the sheep, opening their mouth to the right where the sheep are. So it's below the x-axis and between the what? Between the critical values. Hey, guys. Below the x-axis, between the critical values. That's why we call this BB. Below and between. Are you with me? You feel me, my brothers and sisters? And this is the answer. Do you know what, guys? 2 marks for this answer. If you write this answer in any other way, you are wrong. You can't put this answer, you can't say this answer, you can't write this answer this way and say x is, let's say, greater than -1/3, or x is less than 1. No, guys, you can't write this answer separate. This answer must be written as a compound inequality, like this. Please, people, not separate. Below and between. Okay? Okay, are we together? Are we together? Rational inequalities. You would actually say these are rational inequalities. Remember, that's x to the power 2, right? X to the power 2 over 1. Okay, so these are rational exponents. So you could say they are rational inequalities. These are rational inequalities, and they are part of the syllabus, grade 11. Okay, I don't know if that answers your question, but they are. Okay, yeah. So I don't know if there's Presh, what are you saying? Is it not? Is it not what? Look, it's saying less than or equal to 0, meaning where? For y, where y is negative. Where is y negative? Below the x-axis. Where is below the x-axis? Between the critical values. So all of these inequality signs, they are in this direction, from -1 to 1 to 1. Let's not forget the what? The equal sign. Let's not forget the equal sign. Why do we put the equal sign? Because it was there initially. Because we are not looking for just where the answer is between. It's also below the x-axis, we are also looking for the answer where it is on the x-axis. So we do include negative 1 over 3 because on the x-axis, that's where negative 1 over 3 is, and we do include for 1 as well. So we put the equal sign in between. Okay. Yes, you are right, Presh. That equal sign must be there. Why? Because in the inequality, the factors itself, the equal sign was there. If there was no equal sign, then it wouldn't be on the x-axis. Then it means that there's no equal sign beneath the less than sign. Thank you very much, Presh. You see, Presh, that's why I'm saying to you, Wena, I guess the fact that you don't have a teacher, it's not going to be a train smash at all. X to the power 2 minus 1 over x. The 1 minus 1 over x. Oh, so the ones that have fractions. Yes, they can definitely be tested. Definitely. Okay. Oh, Cindy is saying, can you please explain again? What do you mean? What must I explain again? Like, you're saying explain again to mean everything. Cindy, please make life easy for me. That when I explain, listen so that when you do instead, never returns. You see? Yeah. Okay. So I'm going to re-explain this question here that I just did. We had negative x squared. I understand pressure. Pressure and pressure. Say pressure and pressures are playing there on the comment section, having fun together. I don't know if it's just the press thing that's happening there. Negative x squared plus 5x plus 6 less than 0. Because the coefficient of x squared is negative, because the first step is that we need to write the equation in standard form where a is positive. So divide by negative all terms. We get x squared minus 5x minus 6. And then the inequality sign does what? It changes direction from less than to greater than. That's what happens when we divide by a negative. When we divide by a negative, this inequality sign must change direction. It has to. It can't not change direction. That's what happens when we divide by a negative. Then we get to this point. X squared minus 5x minus 6. You see the inequality sign? It changed direction. Now we have greater than 0. Then to factorize. We've just factorized. Greater than 0. Next step after factorizing, find the critical values. After factorizing, we write down it's like we're writing down the roots of if this was an equation. Those roots are what we refer to as the notation of the answer. The first critical value, negative 1. The second critical value, positive 6. Then we represent that graphically because this is a representation of this expression, x squared minus 5x minus 6, where a is positive. It's a smiley face. We put the critical values, which are you could say, our x-intercepts if we're drawing this graph. This is negative 1 and 6. Then after output means y. Output value. X means input. This on the other side means output. So where is y positive? Y is positive where? Above the x-axis if we are looking at the Cartesian plane. All values of y above the x-axis are positive. But where does the answer lie? It lies away from the negative 1, where x is smaller than negative 1. In other words, where x is less than negative 1. Okay? Are you with me? Okay? I hope you are with me. Then, from here to there, this is where the graph is below the x-axis. We are not looking for where the graph is below the x-axis. We are looking for where it's above the x-axis. So we have no answer. Two different critical values. And I repeat, this is very above, and then that is coupled with away from the critical values. X is less than negative 1. X is greater than 6. It's always the case when it's greater than 0. For y, we know that's where y is positive. And y will always be positive above the x-axis for a function that is concave up. Always, guys. Always the case. Hey. Ready, set. Okay. All right. So I hope we get this AA thing. Above the x, that's where y is positive. It's above the x-axis, which means away from the critical values. That's where the function's above the x-axis, away from this critical value. On this side, on the left, that's x less than -1. That's our x-axis. 1 mark for the other critical values. So 2 marks, guys, for the answer, the final answer. Please, people, make sure you write the answer. Greater than 0 for 2 different critical values. Please take note, this is for 2 different critical values. You either have AA or you have, for 2 different critical values, you have either have AA or you have what? BB. Look at this one in that form. Second step, factorize. So we factorized 3x plus 1 into x minus 1 is a representation of 3x squared minus 2x minus 1. Less than or equal to 0, that sign has not changed because we didn't divide by a negative in this case. Next step, find the critical values. These are the critical values. The first one and the second critical value. X is equal to -1 over 3, x is equal to 1. Next step, and critical values. So this is where for y, where y is, if we say less than equal to 0, this is where y is negative. Negative, but it's negative for who? For y. So that's where we are talking about which area below the x-axis. Which x values show us below the x-axis? Between the critical values. That's why we refer to this being below, between, meaning BB. So for two different answers, equal means on the x-axis. Okay, so we need to also include on the x-axis. So when we write our final answer, this red shade represents below the x-axis, but below the x-axis for y, where it's negative, it's between equal to x, less than equal to 1. 2 marks, 2 beautiful marks. Please, people, the graphical representation is important with the critical values. I beg you, do not forget it. Very key. The standard form is very key. The factors are very key. Everything is very key. Are you keyed? So hopefully my friend who said, please repeat the explanation, you have been repeated. Do you feel repeated? Do you feel understood? Do you feel understanding? You see, it's sad for me when people who said repeat, they don't comment. Screenshot the rules, please. Here are the rules, please. Okay, let me... there they are. Step number 1, write equation standard form where a is greater than 0, meaning where a is positive. Step number 2, factorize. Or you can use the quadratic formula if factor, which is on a number line. Then step number 5, write the solution as an inequality or use interval notation to express your answer. Maybe some of you were like, Haibo, but we didn't see interval notation. How would you write the 2 answers, Meniere, that you just wrote as your final answers in interval notation? I'm just going to show you now. This one, I will, my press, I will. Infinity to -1. Or 1 to infinity to -1. That's a representation of this x less than -1. Then I use this symbol, which is like, it means or. Or you can write the word or. Alright? And then, so this is what we refer to interval notation. You say x is an element of, from, not infinity, negative infinity this side. Because we are coming from negative infinity from this side to what? To -1. But since there's no equal sign, we use open brackets, interval notation. Okay, we use open brackets when something is not included. -1 is not included. 6 is not included. Infinity will never be included. Why? Because infinity is not a number. It is a concept that reveals that numbers, they go on forever. I will love you forever. And you're such a liar because you know that you're not going to love them forever. You just want them to feel like, you know, that they are special. You know what, you know how you guys do, you know, teenagers, for crying out loud. Anyways, this one, -1 over 3 less than equal to x less than equal, the equal sign, we are including -1 over 3 and 1. So we can say x is an element closed bracket, negative 1 over 3 to 1, close bracket. This would also be an acceptable way of writing this answer. What do you mean by what? Interval notation. From negative 1 over 3 to 1, that's where we find that y is negative, or where the function is below the what? The x-axis. What? Alrighty then? You can choose to write in interval notation, or you can just leave your answer in what? In inequality form. I just wanted to explain why they say here, write your solution as an inequality or use interval notation. It's up to you. You want to use what one? Interval notation or inequality? You must choose. And remember, AA and BB only apply when there are two critical values that are different. And I will hopefully get to those kinds of beautiful situations. Okay, so let me finish off the rest, because that's what Landuka was asking. Will I finish all the corrections? Oh, definitely yes, because I'm sure most people wanted that, right? So let's move. X squared greater than 3x. Transpose the 3x. Common factor, and it's what? It's x, the base that has the lowest exponent. Next step, CV, x is equal to 0 or x is equal to 3. Oh, standard. What does this mean? Greater than 0 means above the x-axis. So this is AA, above the x-axis, away from the critical values. So our answer lies this side and this side. So x is what? Less than 0 or what? X is greater than 3. So God, this thing. Do we need to put an equal sign underneath? Do we need to put an equal sign, Presh? Above the x-axis? Mpume says no. Why not? I agree with you, it's no, but why not? Why don't we put an equal sign underneath as well? Is no equal sign here, so why put one? Why put things when they were not given to us? Thank you so much, Mpume. Thank you, Mpume. Thank you, Mpume. Thank you, Mpume. Okay. Let's wrap it up. Let's wrap it up. Difference of two squares. So we open two brackets. Thank you. X plus 1 minus 1. No, it's not gonna ring. It's not gonna ring. Hello, Walker. I'm sure you guys can see what I'm doing above the x-axis, and two different critical values, so it means away from the critical values. So you already know where the answer lies. It lies away, A, above and away. So therefore x is less than negative 1 or x is greater than 1. How easy? How do we see the coefficient? Yeah, if you want to, but you do that. If x squared is negative, so we divide both terms, everything, by negative. This becomes x squared positive. This becomes negative 4. Obviously, it doesn't really affect the 0, but then the inequality sign what? Changes direction. We factorize. Difference of two squares. Two different critical values. And then last but not least, what does greater than or equal to mean? Above, okay, and away again. So it's above the x-axis and it's on the x-axis as well. We have an equal sign as well, so that means above x will be less than or equal to negative 2, or done did it done. Okay, guys, I think that pretty much helps us get an idea of inequalities. Concept of inequalities, at least I'm sure we can kind of get the feel, especially with two different inequalities. What happens, and I'm just going to look at one scenario right now. I just want to look at a scenario here right now very quickly. Squared minus 6x plus 9 is greater than or equal to 0. East, west, south, north. East is asking, you beast, is asking, are you always live? I want someone to answer him in the comment section, not me. X squared minus 6x plus 9 is greater than or equal to 0. Someone tell me the factors. Plus 9 means what about the bracket? The signs of the bracket. Then the signs in the bracket will be, you follow him so you will know when he's live. Thank you. Mpume has answered you so well. Yes, Precious, they are the same. So I know you guys have said 3, 3, but the question is, what will be the signs of those 3? Precious, 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 how precious you are. Critical values. X is equal to, let's be specific. X is equal to what? Critical values. X is equal to 3. Yes. Squared. Very good. Very beautiful. I love this. Okay. Why are they negative? Alitemba Tsotsi. If we still remember what we did in grade 9 and grade 10, when we factorize the trinomial, when the constant term is positive, when this guy is positive, the constant, they will be the same according to who? Yes.
He built it. I decided no time to do homeschool.
Okay.
I like that. Mommy says, I thought you got the blue case.
One root that's there. Okay. Now, practically speaking, people, this is what it means. It means A positive means this is what it means, guys. All right. Okay. Now, this question, please, very important. Remember, for all the questions we were busy with, we were always getting what? 2 different critical values. But all of a sudden now, we get 1 critical value. Okay. If I was speaking, love it. Fafa, I hope you've been answered. Presh answered you very well, very well. So x is equal to 3, guys, there. All right. And this graph is concave up, but it does not have 2 different critical values. Pass through 2 places on the x-axis. No. Nonsensical. There's 1 critical value, so it must. Method of yours with a parabola is just making life complicated. Good people, let me say this and say it again. You guys are going to do functions very soon. And when you do, eventually I've been telling you, this is for who? Is it for y or is it for x? This is very important. Greater than or equal to 0. This is for what? This is for y, guys. What about y? This is where y is positive, people. Please understand this thing. Hey, please understand. Anything greater than 0, it means it's positive. But since this is the output, it means there are questions there for functions where kids tend to not be able to answer those questions simply because they don't understand the interpretation of this thing. And when you do inequalities, it's all fine and well if you can to the idea of using the Cartesian plane and understanding when it comes to functions, what does this actually mean? Hey, this will help you in the future. So if you are able to flow very nicely with your understanding of this thing, it will make things very easy as you go along, especially in functions. Then you'll see, bah man, functions is nothing. It's nothing. It refers to y. This is where y is positive. But where is y positive, people? That's why we say above the x-axis. Here we can clearly say above the x-axis. At least we get that part. That's understandable. But now we don't have two critical values. So saying away from the critical values is not really as accurate as you would want it to be. We need to look at this situation. Okay? Very important. I don't understand. Signs on the side when you're done. Please just make us understand signs on the side. What signs on the side? What do you mean by signs on the side? Please make us understand signs on the side when you're done. Which signs? Greater than, less than, greater than, less than. You mean, what does greater than mean? Greater than. If there's greater than and there's a 0 next door, then that means anything greater than 0, you would know anything that is 0. Okay, so something bigger than 0, that's what it means. This here, less than, means something smaller. Smaller than what? Okay, smaller than what? This is basically what it means. So I don't know. So for y, this is where y is positive, because anything greater than 0 is what? Is positive. Meaning it's above the x-axis. So we can talk about for this greater than what it means. For y, this is above the x-axis. When we say equal to 0, we are saying on the x-axis. Two things, people. Yeah, so greater than 0 here, like exactly on the x-axis. So here we are looking for two things. We are looking for where the graph is above the x-axis. We are looking for where the graph is on the x-axis. Now we'll need to look for the x values where the function is above the x-axis, meaning that's where y is positive. And then equal to 0 means on the x-axis. That's where equal to 0 means. Equal to 0 means on the x-axis. Hey, people, I hope you are hearing me here. So we're looking exactly where the function lies on the x-axis. Okay, so hopefully you understand this thing, because interpreting this thing is basically the thing that helps you be able to write your answer. Yeah. So now let's look at this thing. You remember I said our graph now is not going to cut into two places. It's going to actually just go down and touch this critical value, then go up again. So above the x-axis, yes. Up from where until where? From in x-axis. So you can clearly see, guys, that from negative infinity to infinity. All right. In other words, where is it above the x-axis? It's above all the way from that side. At 3, we can say it's on the x-axis, meaning here or at 3, where x is equal to 3. When x is equal to 3, that's where it's equal to 0. Okay, y is equal to 0. So when x is equal to 3, y negative infinity, just before 3, the function is above the x-axis. At 3, it's on the x-axis. From 3 onwards to positive infinity, the function is above again. So what then can we say? We can actually say, we can simplify it and actually say x is an element of what? Of real numbers. I mean, these two ways are just two different ways of expressing the same answer. This is interval notation. Okay, and this is basically you expressing your answer succinctly, sense, guys, because the function will always be above the x-axis for all x values. In other words, all x values, the function will be above. There's nowhere in this, and where is it on the x-axis? And I'm telling you, it's where x is an element of any real number, that function will be above or equal to 0. X squared plus 6x plus 9 is less than 0. Let's check this one out. X squared plus 6x plus 9 is less than 0. Is it standard form? Yes. So next step, factors. X, this positive sign means critical values. Critical values, x is equal to -3. You can see, guys, okay. No, I'm not going to do trigonometry today. No, solo felang. Why in the world would you say I'll be doing trigonometry? No. Okay. Like I said, guys, there's a particular order that I'm doing things, and each session that I do still a ways off from me being able to do it. Okay. So critical value x is equal to -3. Then one critical value, the graph. Again, the graph is like this. And then what I do is that at -3, I have this open dot. The reason why I have an open dot is because you can see on the x-axis, right? So I write this open dot as an indication that obviously, okay, we are not looking for when it is equal to 0. But we are looking for it where the function, what does less than 0 mean? Is it negative? Below the x-axis. Are you with me? Below the x-axis. And unfortunately, equal to 0 is not there, which means on the x-axis, there's no answer there. So basically, my question then to you is there a place where you see x values? Okay. Is the function ever below the x-axis? Will it ever be below the x-axis? No. So therefore, what do we say? X has no solution. And the reason it's because of this condition, because here we have to conclude that x has no solution. Interestingly enough, had the question been slightly different, and let me show you what I mean by that. Let's say the question was like this. Let's say it said x squared plus 6x plus 9 less than equal to 0. Then obviously we would do the whole factor thing, plus 3 less than, right? Then we know the critical value is -3, but check me out this time round. I don't put my open dot there. The reason being I still apply by interpreting this. For y, what does this mean? What does less than 0? It means for y, we're looking for when y is negative. All right? And so below the x-axis, are we ever going to find this function being below the x-axis? Will we ever find this function being below the x-axis? Okay, since there's one critical value, and this function just basically touches that critical value, and then it goes up again. Will we ever find this function being below the x-axis? So does less than 0 have any x value whereby the function is this? Are we going to get anything there? Okay, Bume, no, definitely not. But let's look at the second condition. My question is, where do we see the function being on the x-axis? What x value shows us the function being on the x-axis? Because equal to 0 simply means on the x-axis, meaning on the line. And on the line, what is there? What's touching on the line? Which x value is there? x is equal to negative 3. That's it. That's it. Because for less than 0, we have nothing. Because below the x-axis, there's no x value showing us the function being below the x-axis. So we have nothing for below the x-axis. But for equal to 0, it means on the x-axis, we have something, and that's x is equal to negative 3, the critical value. Okay? Very important, these things. Very, very important. Please take note, people. 2 critical values suggest one sign and interpret what this means in order to be able to write down our final answer. Guys, I hope this is so clear to you guys. Clear as clear as clear as can be. All right. Right. Now, since I feel like I have so much passion and love for what I'm doing, and I'll give you your game challenge and you can have fun with that, and that will be that. I want to actually go ahead now and do the next topic that I wanted to do for grade 11s, which is still under quadratic equations, simultaneous equations. All right, and I'm just going to do one example till we meet again. All right, and I'm hoping that you guys will take full advantage of the fact that you now know how to answer inequality questions that have to do with when you have 2 different critical values, using AA and BB as sort of like a key reminder once, and then you need to always interpret what the inequality sign is saying to you with regards to y, and what it means with regards to the equal sign, if ever it is there. If you have that down, then at least you have accomplished so much in quadratic inequalities. Anything else that is integrated into us, I will give you some challenge questions. Have fun with them. I'm going to do simultaneous equations, and I want to look at simultaneous equations. Simultaneous equations, the word simultaneous means at the same time. So what are we doing here? We are finding values for 2 variables that will satisfy at the same time. In grade 10, you guys did linear equations, how to solve 2 linear equations at the same time. It was linear equations, right? 11, you take it one step further, where you solve 2 simultaneous equations, and those simultaneous equations are usually one linear equation, as you can see here, x plus 2y is equal to 5, and a equation that is quadratic in nature. An equation that is quadratic, those types of equation. One linear, the other quadratic. So let's look at the method where you have a linear and quadratic. The equations are not limited to just linear and quadratic, but for today, I will explain how to solve an equation that has a linear and a quadratic equation. How to solve those 2 simultaneously. You can see the variables that are here that are unknown are preferably of that linear equation, the subject of the formula. In grade 10, you guys did how to make a certain equation, how to make a certain variable in an equation, the subject of the formula. I'm sure you remember that. I think you guys, the topic was called relate them using the additive inverse and the multiplicative inverse, and then transform those types of equations so that you make one of the variables the subject of the formula. So here they are saying we might need to make one of the variables of the linear equation. So you seem to take the linear equation and you manipulate it, make the subject of the formula one of the variables. Step number 1. Step 2, you substitute then this equation that you have turned into the other equation. Usually step 2, and when you do that, when you substitute, very important, I'm going to write this, you use what? Brackets. Please use brackets. Brackets, brackets, brackets. Please, brackets, brackets all the way. Step number 3, write that quadratic equation. You can go ahead and solve that equation and get that one unknown that will be represented in that equation, because the equation you will then have formed, which is standard form, it will have one unknown. Okay. Then number 5, you go and substitute them back into that equation that you had made the subject one of the variables for that particular equation. You substitute these values into the linear equation to find the corresponding values of the other unknown. So these are the steps that we utilize to solve an equation where we have a linear equation and unpack it one by one. Do you see this linear equation? Is it beautiful? I am sure you can see it's beautiful. Now what you want to do is you want to make one of these variables the subject of the formula. So if you look at x and y, which one, coefficient of x is 1? Or is it y that we can make the subject of the formula? Okay, which one do you think looks more favorable to make the subject of the formula? X or y? Okay, and whichever one is popular and seems to get clout in the comments, as you see x appear on the screen, all right, hopefully you can see that the coefficient of x is 1, which is probably why it is more favorable to make that variable the subject of the formula, because its coefficient is 1, and the likelihood, okay, so it's better than to make that x the subject, which is fine. Okay, so we're going to go ahead and make that x the subject of the formula, all right, and so it was initially equation 1, we made x the subject. Now it is 5 minus 2y. We say it's equation 2. Then the other one that you had, 2y squared minus xy minus 4x squared is equal to 8, to equation 3. Okay, so remember, this was the initial equation, remember, the linear one. We made x the subject, our first mark inside the bag. 2, substitute this into the other equation, usually the quadratic, using brackets. So what are we substituting? In the place, we substitute 5 minus 2y, and we use brackets, and we substitute that 5 minus 2y into equation 3. So that's why we are saying we substitute equation 2, this one, into equation 3 equation, and we are going to substitute 5 minus 2y where x is in this equation. So we're going to rewrite this equation. It starts with 2y squared, nothing to substitute there, followed by what? Minus what is next. Now I can clearly see that there's a y that follows the x. So what I'm going to do is I'm going to mentally change the x and the y around. Why? Okay, to avoid leaving y behind. And this is very important. Did you see what I did? This y, I wrote it before the x. Remember, multiplication is commutative. Order doesn't make of me not being able to misinterpret what I do with the y if it was situated this side. I'm going to put the y before the x, then substitute, so that I can have a monomial multiplied by a binomial. Hopefully you get this thing, people, because sometimes people will leave this y here. It's easy when you make sure that the order, all right, accommodates, for the sake of convenience, the distribution of the monomial into the binomial. Who is hearing me here in the house? Can anybody say amen in the comment section because you feel me? Or maybe you are not really listening. Okay, it's very important that you do that. It's going to end up in quadratic. Then you minus 4 in the place of x. Remember, in the place of x we are substituting 5 minus 2y. 4. 5 minus 2y squared equal to what? To 8. Then we continue, pick it up from there. Times negative 2y, negative times a negative is positive. Sign, y times 2y, 2y squared. You see? That's why I arranged and change the order to accommodate for convenience so that the y, negative y, actually is distributed into the two brackets. Sometimes that y, if it was here, so that we open two brackets and distribute. So 5 minus 2y into 5 minus 2y. Okay. Okay. And this is me. We get 25 minus 20y. Now, minus 20y because minus 5 times negative 2y gives me negative 10y. And I get another negative 10y. And together this squared. This negative 20y, I will repeat, 5 times negative 2y gives me negative 10y. And then a negative 2y times another 5 gives me another negative 10y. And together, when I add them, I get a negative 20y. That's why I close this 8 and write negative 8 equal to 0. Going back, I am intending to add the like terms the minute I am done with the distribution of negative 4, because this negative 4 must be distributed to all three terms, which is very important. I get negative 100 plus 80y, because a negative times a negative is, and y squared minus 8. Now it's time to add like terms together. All right. All this is so that I can get my beautiful standard form. 2y squared plus 2y squared, right? Minus 16y squared. Those are like terms. Minus 5y plus 80y and negative 100 minus 8. So this is me bringing my like terms together so that I can see them and then do my addition. There is this expansion that you need to make sure that you accurately do. And if you think about it, this is all grade 10 work. All of this that you are doing from here all the way from here to this is literally grade 10 expansion. You monomial by binomial, binomial by binomial, then adding and subtracting like terms after that, and then negative 12y squared, negative 5 plus 80, you get, hopefully you can see that it's all coming on. Okay, then the $1 million question is, if you look at this, negative 12y squared plus 75y minus 108, obviously if you divide by a negative, this is what you get. And now some people may look at this and be like, this is too complicated, let me just go ahead and use the quadratic formula. Okay, now you can trinomial that you guys can see. Is 3 a highest common factor? Does 3 go into these numbers, like all of them? Is 3 a highest common factor? Well, let me ask you, is there a highest common factor? Let's put it like that. Is by the highest common factor. So we get 4y squared minus 25. This is division by 3 for all terms. Plus, what's 108 divided by 3? Okay. Yeah. And then actually this is factorizable. So someone said you cannot factorize this, but you can actually factorize this. It's factorizable. All right. You wouldn't be at fault if, let's say, for instance, in this stage, you use the quadratic formula, but we can factorize this. Okay. Definitely feasible to factorize. Quadratic formula is usually x is equal to minus b plus minus. But remember, since you have y, you would have to just remember that you are working with y. So your quadratic formula will have to be y is equal to. Okay, don't say x is equal to, because that would be a problem. Okay, so I know some people would actually not see the factorization, the factors in this, but there actually are factors for this. And the factors are, if we don't use the quadratic formula and we actually factorize, no, there we go. Easy does it. Okay, 4y minus 9 into y minus 4. Okay, for those that can factorize just simply by trial and error and just get the factors. 4y is equal to 9, y is equal to 4, so y is equal to 9 over 4. So those are our y values. Y is equal to 9 over 4, or y is equal to 4. Now, someone will think that they are done, but you are not. You then take these y values, both of them. Remember, there was a equation that you basically made the subject of a formula x. It's ready to take on the y values so that you can find the x values. So you take those y values, you go back to this equation that you had changed, because it is ready to give you the x values. Minus 2. 2, and then in brackets, in the place of y, you substitute 4 for the first one. You get 5 minus 8, which gives you negative 3. So x is equal to negative 3. Or you take that same 5 minus, in brackets, you substitute 9 over 4. 5 minus 9 over 2. And the final answer there is 1 over 2. Okay. So you can conclude negative 3 and y is equal to 4, or x is equal to half and y 4, or when x is equal to half, y is equal to 9 over 4. Now people are saying this is a lot. Yes, it can range from between 6 to 7 marks, the question itself, when you answer it. Now just show you quickly where making either x or y the subject of the formula. So that's the first mark. Second mark is when you use brackets and you substitute correctly in the other equation. They'll usually give you a fourth mark somewhere just for simplification, and then they'll give you another mark for standard form. Then they'll give you another mark for factors. They'll give you another mark for the actual y values. And then when you substitute and you get the corresponding x values correctly, they'll give you another mark for just the x value. Okay. Remember that quadratic formula. So people, here's the thing. If you cannot factorize, then you use the quadratic formula. Okay. And the thing is, sometimes some of you will get here and you'll be like, hey, I cannot factorize this thing. So if that is the case and you use the quadratic formula, that's perfectly fine. Okay. So some of you may use the quadratic formula, but then caution. Please, if you saw that the working variable is y, please guys, if you see that the working variable is y, don't forget your quadratic formula has to be y is equal to minus b plus minus b squared minus 4ac over 2a. You go about answering the questions. Okay. So I repeat again, the marks, you get a mark for making x or y the subject. Okay, and usually sometimes people lose marks here. They take 2y over, it doesn't change sign, then they get penalized for 1 mark because they didn't do that correctly. What a basic mark to get, guys. Then substituting using brackets in the right place. Most x is supposed to be replacing any value of x in the other equation. So where x is, that's where you write 5 minus 2y. There it is. Where x is followed by a squared, that's where you write 5 minus 2y followed by a squared. Then you have all y's. So you're in here. But you know what? It all actually really just becomes a single mark if everything is done accurately. And accuracy is important here. Your distribution. Okay? No. Tyrant, we do not complete the square. Remember, using the completing the square method is a method we only utilize when it is explicitly asked in the question to do what? To solve for a particular variable using the completing the square method. So let us not utilize that method except when it is asked explicitly. Okay, so simplification marks sometimes, and then standard form. Your standard form won't be correct unless there is the simplification is correct. Okay, tyrant, I repeat again, okay, it is a method that we use to solve for x, but it is a method used to solve for x only when it is explicit. We use the factorization method to solve for x, failing which, if the factorization method cannot be done, we utilize the quadratic formula to solve for unknown variables where a quadratic equation is concerned. Like I said, then standard form gets 1 mark. Factorization, if you don't factorize, in the case where you use the quadratic formula, that's also just 1 mark. Getting the y values is the next. You get a last and final mark for getting the x values correct. Okay, so that is 1, 2, 3, 4, 5, 6, and like I said, a glorious 7 marks. Okay, and in most cases, or some cases, sometimes depending on the situation, it may be 7 or 8 marks. It just depends on that particular question. Okay, no effort to basically be here on the live today. So unfortunately, my friend, I'm very sorry. This is basically where I bring this live to an end. Okay. Other things are calling for one's attention at this present moment. So I'm going to leave you with some game challenge problems. And for those who have been on this live platform before, you will know that master the concept that has been covered in the live session. Any other serious student would probably be having a textbook open and is probably like, okay, I finally get it. Okay, which is very critical to do when you are someone who is serious about the marks. Okay, game challenge number 1. Solve for x. Remember, we did inequalities today, and so I'm just going to give you a few, and then I'm going to give you a few solve. 16 less than equal to 0, second one. Just J for control, if you know what I mean. Challenge problem, my friend, challenge problem. Okay. Definitely give you problems that are within the context of what I've taught, and just some others that are just to see and check if you basically can probably do some research and find out, and then maybe you can wow me when you send me your work or whatever, and I am just totally baffled and wowed by how you did. Nothing personal, so don't take it as such. Solve for x and y. All right. There it is, guys. There it is. There it is. Okay. Let me just remove the comment section so that you guys can take the game challenges for the inequalities, and I'll just give you a minute to screenshot or to or whatever you need to do. But that's x squared plus 8x plus 16, so that's a 8. This is x squared plus 2x plus 3 is greater than 0. Negative x. Then this question, solve for x and y. Okay. Y is equal to x plus 2 and x plus xy is equal to 4. That's the first one. Second one is x minus 2y is equal to 3 and x squared minus xy minus y squared is equal to 1. 3 x squared minus 4x and x squared plus xy minus 3x minus y is equal to 0. That's number 4. And the last but not least, number 5, 2 to the power x plus 2 to the power y is equal to 8, and x squared plus y squared is equal to 5. Okay, thank you so much. I hope that then helps us navigate that space. How come you master maths? What do you mean, how come you master maths? It's because I've been teaching maths for quite some time. So, I mean, if you want to master maths, you must, you know how crazy obsessed you guys become with a boy or a girl when you are like, I guess, obsessedly, madly, just whatever. That same obsession needs to sort of, don't you guys lose yourself in the moment when you are obsessed with this particular entity? And you know, like in all idealness, you know, and he doesn't understand our emotions, and you channeled it, you know, into in this positive direction towards your academics and stuff, then that's where the mastery would come, because it would be fueled by the love and the passion that you have for your end. I understand, press. Okay. So yeah, that's all I have to say. So that was it for today, people. Thank you so much for joining. It had been a while, right? Yeah. You know, when schools are back, pressures to sleep and not submit before time. I can't drag alive and have like long overdrawn sessions, and also I can't accommodate other grades in the manner that I would want. So until you hear from me again, what time does the live start?